All right, we'll go ahead and get started here. Thank you for the introduction. A little about myself before we go ahead and dive in head first. Josh Danielson, I'm a senior security manager within Axway. Axway has a greater organization focused on B2B, EDI type of software. As cloud has kind of exploded, we've opened up our new cloud computing division probably about 7 years ago, and I've been heading up all things security since then. So I've been with them for about 4 years, and I was probably the first security dedicated hire since things got started. It's been an interesting challenge because we've taken a traditional software company and tried porting them over to be a true cloud company. So it's been a very challenging, interesting process we've been going through. I got my start in DoD. Moved to the academic space, did some stuff around there, moved to Axway, and actually I'll be moving over to head all things security at Capital One in their new cloud computing division at the end of this month. So things keep on going, as we all know. Feel free to follow me on Twitter as well. I keep pretty active on there. What's the first thing people think of when they think of cloud? People think secure, right? Well, yeah, not so much. Despite all the newer technologies and all the advancements that have been made in cloud computing, it's still not a trusted platform by and large. But we all know saying no is a security failure. We've all been to experiences in all of the meetings before that all the infrastructure and all the application, all the developer folks will get in one room, and by some reason, all the security people don't get invited. I know I haven't. I think a lot of you actually have as well. There's a very good reason. Security people hold things up. They don't see value add a lot of times. And I think that's one, in our cases, where we have to do a better job of communicating what we can actually do, giving them more options, and actually showing true value add to the organization. Outsourcing in general. One of the first things we discuss in information security whenever we talk about cloud is you can't outsource your critical functions. That's insane. They control the data. You have no control over it. Well, we do these things every single day, right? After all, we don't have money stored underneath our mattress, and despite no one trusts the big banks, we trust the overall governance and the overall structure in which these components work under. Cloud computing is still continuing to mature, so I'm not in any way comparing it to something much more mature as far as the banking industry. We have the FDIC and all these other kind of checks and balances, but it is getting there. This is one of my favorite quotes from a CIO that's formerly with the U.S. government. Basically, he sums it up in one long sentence. Amazon Web Services, Google Compute, all these large platform providers, they have experts that can do these things and can focus on these security tasks better than any one of our groups more than likely can. So it's kind of a more important thing, and that's why some of these organizations such as Amazon Web Services can have true enterprise type of platforms that we can piggyback off of. So I'm going to preface the rest of everything I'm saying. Within Axway, we do use Amazon Web Services. I'm not going to say they're the best cloud provider or they're the only one. If you're into Gartner and all that other kind of marketing stuff, they're at the top right corner, which is a good thing. So just kind of one word note, I don't work with Amazon. We don't have any other partnership besides we use them. I'm not getting paid for them. But the rest of my conversation will be a lot of focus around Amazon Web Services technologies. The shared responsibility model. This is probably one of the few things that throws a lot of security, and especially a lot of seasoned people off. I regularly get in discussions with auditors and a lot of potential customers, and they bring the security folks in. And then we go through the traditional audit, the hoops and whatnot. And one thing they actually don't understand is what you're responsible for as a customer, what the provider is responsible as a provider, and what our customers are responsible as a customer. So you can take a nice look right here. This is one of the things I stole from Amazon Web Services. They have a lot of documentation, a lot of white papers, some really good stuff. If you're really interested in learning some more, it's freely available. There's hundreds of pages of this stuff. You can dive in head first and get a better idea of their security programs and recommendations. So we talk about the blue stack over here at the top of what they recommend you do as well. So this is kind of an important distinction. We're going to kind of strip away some of the layers of the cloud and explain why this is actually more important. When we strip away the layers of the cloud stack, you can see that kind of blue area. Amazon Web Services functions at the very bottom, and infrastructure as a service. As you go up, you see platform and software as a service. These are the areas that people become a lot less comfortable with, and I'll give you one specific example. I know work with auditors quite a bit, and customers and PCI and others of the like. They come in and say, do you do logging for failed logons? Well, we do at the operating system level, at the infrastructure as a platform, infrastructure as a service level. So we check the box and keep going. Unbeknownst to them, they forgot to ask about any other stuff. And these are seasoned people who have been doing this stuff for a very, very long time. They just don't know. So knowing your shared responsibility, knowing what cloud solution you're looking at, who you're looking to partner with, and what you as a as a customer are looking to get into, it's really critically important you understand what service you're looking at. So know where you're at in the cloud. But if you suck now, you'll still be pleasantly surprised at the lack of change when you move to cloud. You're still responsible for doing the same stuff. And although Amazon Web Services may take care of the data center, and they may take care of a lot of the physical stuff, and they may take care of some of the other things, basically the Mason-Dixon line is right below the hypervisor, which is at the operating system level. So you're responsible for within Amazon Web Services for doing the guest operating system, so Red Hat, Windows, whatever it may be, and they run some bastardized version of Zen that they run underneath that, and they're responsible for doing that. Same thing on the network side of the house. They run all the network hardware. You're responsible for doing all the stuff right above that. So you can still have the capability to do network ACLs and whatnot. So instead, what we're left with is not inherently a secure or unsecure cloud, but a platform that can be secure for certain use cases when used appropriately. So a quick rundown of agenda items. I'm going to go over cloud principles, understanding what a cloud actually looks like. There's been a lot of misconception as far as what the cloud actually is. I have to constantly report back to my boss and tell him all the crap that's coming out that is just complete garbage. So all the stuff that's coming out recently around the business side of the house is that cloud is not cheaper. In fact, it's actually more expensive. Well, when you do this thing called cloud washing, you take your traditional software, you plop it on an EC2 instance, and you call yourself cloud. Well, yeah, that's not actually cloud, and you're actually spending more money. We'll go into a few more use cases how you can actually take advantage of the cloud principles, and you can have a really true cloud solution. So that's kind of an important distinction. When we talk about Cloud 1.0 and Cloud 2.0, you will never do patching again. You will never do vulnerability scanning again. People will never, ever log in or SSH, RDP, otherwise directly into a box. I'm talking about admins, root, otherwise. I'm not just talking about users. I'm talking about no one. The SSH 22 is off. Security and DevOps, we'll kind of talk about how everything kind of merges and blends into a cloud DevSecOps model. And then how do you actually manage this scalability? When we look at some of the true unicorns in the industry right now, if you want to take Netflix as an example, when House of Cards came out a few weeks ago, it was rumored that they were using 1/3 of the entire internet's bandwidth at that single weekend. That's pretty freaking insane. How do you manage all these systems that are coming up and down? So you have Friday night comes up, everyone turns on their House of Cards, Saturday morning around 1 a.m., everyone spins it back down. They have to stand up hundreds of systems, thousands of systems to actually facilitate this. So we'll talk about how do you actually manage that type of elasticity in these environments. And then a little peek about what's coming next. So cloud principles. The first one is service-based. So this is the commoditization of IT. We all know what this is. This is you plug in your lamp into the wall, and the electricity kind of works. You plug this in, you plug in your server, and then it kind of starts working, or you start up your server and it starts working automatically. So that's kind of service-based. We all know what that one looks like. Scalable and elastic. So this is one of the things a lot of security people kind of fight with initially and say, we can't secure this. Systems are constantly coming up and coming down. How do you actually secure this stuff? Well, I'll tell you, this is actually one of the things we actually use to our advantage. When Amazon Web Services was notified and everything came out about shell shock a few months ago, they were actually able to patch shell shock across their entire load balancers within 3 days. When you talk about enterprise and doing any type of patching anything in 3 days is absolutely ridiculous. So you inherently look at it what's something that looks like a disadvantage and you turn it into an advantage. So using elasticity, using scalability to your advantage. Shared. To some degree, there's going to be something that is always shared. I talked about the shared responsibility model earlier. You have to understand where you are in that stack and kind of what you actually have to provide for your customers or what you have to actually manage on your side of the house of things. Metered by use. This just basically means you get a bill at the end of the month, kind of like you get your electric or electricity bill or whatever it may be, and then you only pay for what you use and you don't pay for what you don't. When you're talking to your business people out there, I always tell my boss this is CapEx versus OpEx, and he gets all excited and like, ooh, we only pay for what we use for and whatnot. So the business people kind of love that term when you talk about meter by use. Use of internet technologies. This is really leveraging open APIs. This is using mobile and whatnot to take advantage of some of these type of characteristics. So we'll dive in. Cloud 1.0 versus Cloud 2.0. Cloud 1.0. This is the original Model T. It's good for what it was, but it will no longer suffice. What does this actually look like? So I was giving the example earlier about Cloud Wash. This is the organizations right now that are just taking a traditional piece of software. They spin up an EC2 instance on Amazon Web Services, and they install themselves there, and they call themselves Cloud. Or they come up with a hardened appliance, and they install it into the AWS Marketplace and say, we're into cloud now. Yeah, not really. Don't tell some of these vendors out there because I don't want to blow their mind. Several releases annually. We know what this looks like whenever there's an update of a database, whenever there's an update of major operating systems, and a major update to any type of software. It's all hands on deck. It's a pain in the ass for that whole week. Everyone's on call. You know it's going to be a pain. We all know what this looks like. It's these huge, massive updates that no one knows what's going to happen, but you know something bad is going to happen. And cloud washed. I mean, this is kind of a marketing term that is thankfully starting to become a little bit more used and kind of calling out these people who are trying to be cloud but really actually aren't. So that's what cloud isn't. What is cloud then? So I say Cloud 1.0 and Cloud 2.0. Cloud 1.0 is really just porting your stuff over. Cloud 2.0 is really building your software on top of the platform to take advantage of some of the things that I was describing earlier. So this is building your software on top of the provider. Within Amazon Web Services, they have different types of storage you can actually use. So you can use local volumes called EBS volumes. You can use something that functions a little bit more of a slower SAN. It's called S3. And they have a really long one really for archival purposes called Glacier. If you can kind of tier out your stuff, so we actually tier out our logs, for example, you can actually better take advantage of that. But you have to be able to custom create your applications on top of this. Infrastructure as code. As cloud becomes much more popular, there will be less and less administrators, and there will be much more type of developer types. I can say right now I am not a developer, but I have to spend a lot more time learning JSON, XML, and whatnot, because guess what? My job as administrator and architect isn't going to exist in the same way it does in about 5-10 years or so. You have to learn to code from when it comes to rule sets, when it comes to embedding hardening baselines and whatnot. I'm going to get into the Cloud Factory of how you embed these things in by default, so you no longer have to do patching. You no longer have to do vulnerability scanning. Streamlined agile processes. This is taking advantage of some of those types of things so you don't have to do patching and whatnot. So I don't want to steal too much of the thunder coming down, but I just want to point that out. And what does this look like? Several releases a day. So I know I said the example earlier with Amazon Web Services of how they actually patch shell shock within a few days. Some of these organizations are known for doing a few hundred updates in a single day, opposed to a few every single year. If you learn to take advantage of those, it'll really change the way you can actually manage your environments. So what are a few traits of a successful cloud security program? Some of this we all know is kind of redundant, so I'm not going to dive into that. Know what framework you're working with, have some reference architectures. I know I mentioned a little bit of APIs. One thing I will kind of touch on is some of the logging. Some organizations that are truly cloud and want to really take advantage, the average lifetime for a server is 22 days. That's kind of around the benchmark. That's around the threshold. So no longer are servers these cuddly pets that you keep forever and eventually they die in 6 or 7 years. They're things that actually are constantly rotating on a regular basis. So how do you actually monitor those? How do you actually log those? How do you go back when you're trying to find a host for a system you're trying to look at and it no longer exists because it got terminated 3 months ago? I'll talk about some of those things coming up. CI management. So for any people who have to do all of this type of process or ITIL and all these other types of terms we all know we have to comply with, configuration items. No longer will you ever have to do change management around your servers. Fundamentally, that completely changes because your server's always coming up and down. Instead, your CIs become your Cloud Permission templates, your Docker images, your OpenStat scripts. So that will change, and you will no longer have to have change control on your servers. SSH is off. RDP is off. No one's logging into any of these boxes. They have no reason to. Why does someone actually log into a box for a Linux box to do something? They go in to fix it, to update a config, update some type of parameter. You go back and you change that in your CloudFormation template, and you never have to log into the box. There's no reason to. You shoot the box in the head, you spin up a new one in its place, and it gets stood up and it gets remediated in a few instances. That's how you actually do things, and that's how things will change in that way. CI management. For the first time ever, I came from government. I was doing auditing, kind of analyst work there for a while, and I remember one of the biggest things I actually had. There's always some jerk in the corner who decided that he didn't want to wait for IT, so he wanted to put in his own Linksys router and whatnot, and he had his whole thing going because he had his other personal laptop and whatnot. So for the first time ever in cloud, you actually know what you actually have in front of you. So this is a screenshot that we have in a console. You know exactly what's in front of you. That's a luxury I know I never had in previous environments. You know exactly who's connecting what within your environment. And we kind of take advantage of this with our configuration management tool. We use Puppet. Other people use Chef and whatnot, but Puppet worked in our environment. We bounce the configuration within Puppet against this in real time. So anytime anyone stands something else and it's not enrolled within Puppet, which controls all of our logging, all of our hardening and whatnot, we get a notification in real time if something isn't within scope or anything is being managed by our security teams. So DevOps. What is DevOps? I'll be honest, I've been working in cloud dedicated for about 3 years now. I still don't really actually know. I was doing some item writing for ISC Squared and they're coming out with a new cloud security certification. And they had all these people from NIST and ISO all arguing with each other. And they were arguing if the C in cloud should be capitalized or lowercase. I was like, good God. These are supposed to be the industry experts creating all the baselines and all the revisions you see from NIST. Yeah, that's the state of the industry, I'm sorry to say. So when all these people and my boss and all these other people start using these terms in cloud and whatnot, start misusing them, no one can argue if the sky is blue, because we all know it is, and if everyone says it isn't, we know they're crazy. If someone says cloud isn't cloud and we're misusing things and kind of misusing these terms, it's because it's not defined yet. Even people working on it really don't have a good enough idea yet to come up with a single set of terms and whatnot. I've seen these people arguing. It doesn't make you feel good. But DevOps, it's really just it's a philosophy of how do you actually connect development with operations. We've had a few successful experimentations in this. It's really just making everyone own the whole solutions. Instead of one group pointing fingers at the other and vice versa and whatnot, it's having them kind of collaborate, much more of a collaborative type of culture. And some things we've actually done to make this much more successful. We've made some of our developers be on call and fix operational issues. We've taken some of our system administrators and we poured them on the development side of the house and made them write some code. So having them have dual ownership across the board is really kind of critical to building that culture of DevOps and making sure that you actually build solutions that are much more robust, much more agile. So I talked about this before. We're really beginning to streamline and really assembly line driven asset management. And we're all used to this type of stuff as far as provisioning a new system, and it comes down the line, and 6 weeks from now you get it racked and stacked, and you get it connected, and then you can kind of use it. And we're like, that's the assembly line you use. Well, then everyone kind of goes in and they I'm talking about 100% managed and customized from the get-go. So, like I said before, instead of actually managing servers, we don't manage any servers anymore. We manage Docker images, we manage, if you use OpenStack, we don't use OpenStack House, but that's another one, and then also CloudFormation templates. Those are the things you manage. Those are the things you need to scrutinize and make sure that people aren't going and messing with. Your servers, no one's logging into them. Who cares? They're constantly coming up and down anyways. Those are no longer things you have to scrutinize and worry about because you know from the core, you know from the very start that they're being secured by default. You begin to rely on tagging, logging, metadata. These are what your configuration items are. There are no more snowflakes. No longer are these kind of one-off servers that are kind of floating in the corner by themselves and everyone, oh yeah, that's that one server that does that one critical function, so don't touch it because everything's going to break. This has a heavy reliance on APIs. This is where we've worked with a lot of vendors so far, and we really haven't seen a lot of integration quite yet. We've had to kind of build our own. So allowing all these kind of configuration to be synchronized within, we use Splunk. Splunk's probably one of our favorite tools. That's probably the only one I'll name because that's one of the few that does that really, really good job at doing it. But beginning much more relying on these APIs will really be critical to your success in managing all these systems across the board. So I kind of poked at it earlier, but we're all used to server hugging. Everyone gets a box and they like to cuddle it and like to keep it forever. They like to name it and they have their IP and they have their host name. And these things are really meaningful. Some people actually rely on them. We also used to remember the people who can spit them out and actually remember them off the top of their head and knows every single host within their environment, or at least has a good idea of them. They're static systems. They never really change. They stay up for a few years and they're used to staying there forever. We never really move them. They were going to shift them. They stay the same. They are snowflakes. They're kind of sort of one-offs. Each server is different than the other, and otherwise. What we're looking at now is service-oriented solutions, not server-oriented solutions. So this is where IPs and names become meaningless. I can tell you the ranges, but I have absolutely no clue what our critical boxes and IPs are, and almost no one else in our environment either can. These systems are ephemeral. Like I said, servers are now lasting several days, not several years anymore. These servers become mechanized by code. So, and I'm not a developer, but I had to learn a lot more of the development, JSON, XML, and otherwise, to begin integrating a lot of these components together. You have to also be able to shoot the other node in the head. You have to be able at any moment to get rid of any of your systems, any of your servers, and know that they're going to be resilient enough to come back into place. I know I use Netflix as a lot of example, but they have a tool called a security monkey, actually chaos monkey, and it goes around shutting off random servers throughout the entire environment. The whole goal is that if you're resilient at any given time, when something bad actually does happen, you'll be ready for it because you've already been ready for it. So managing scalability. I'll give kind of a simplified version of this, but I think it's still pretty useful. We call it a blue-green deployment. A few other people are actually using this in the environment too. I haven't seen it cut too much fire yet, but you can find it if you do a few searches for it. Basically, it's this. You have a running stack, you have your green stack, and it's running all the stuff you currently need. So if this is patch management, this may be a dated version of OpenSSL. A new vulnerability comes out, you have to create a new one, so you actually update a new stack, and all this stuff is being done in real time. This is not a whole bunch of server and a whole bunch of time. This is all being done in real time in CloudFormation templates. It takes several minutes to mimic a current environment of a few hundred servers. This isn't a whole manual process that has to take a scrutiny week or so to get done. So you stand up a new environment with the updated version of OpenSSL. You swap this through your load balancers that you have in front. That's kind of the prong, kind of trident thing looking thing in front. And you swap it to the new one. And keep in mind, your static content, whatever it may be, you can see the backend database on the other side in the backend. That stays the same. But your servers that are just doing the processing, those are ephemeral. And then you get rid of the old dated version. So kind of quickly touching on this as far as security management. I know I talked about vulnerability management, patch management and whatnot, monitoring a little bit as well, but this is how things will begin to change. You will never have to patch your systems again because there's no reason to. You update the base image. In Amazon, they call it AMI, an Amazon machine image. You upload that base image, you shoot any type of servers you have in the head, and you replace them and you backfill them. All this happens in a few minutes. So what we actually have a cloud factory. So I want to give one specific example in here of when we stand up a new customer environment. We have our base AMI. We have multiple products, multiple types of solutions, but we have a base AMI, Amazon machine image and it rolls down the factory line. And in there, we're able to embed all of our security baseline. We're able to ensure that Splunk forwarder is actually monitoring to our indexers properly. We're able to ensure we're building out documentation for our customers that need that. Some have some specific requirements that have everything that need to be documented. Some governments and whatnot still want to ensure everything's named and everything's proper. We'll give it to them. We have this all created. This is already scripted. As well, we have performance testing and integration testing across the board as well. From there, we can do our install scripts for some of our customized stuff. And at the very end, you have a lot of stuff. So I'm not just talking about the image. I'm not just talking about a single server. I'm talking about the entire environment. I'm saying network ACLs, security groups, load balancers, all these types of things that you have to create an entire solution on, not just a server or an application or a database or whatever. This is everything that comes into one single piece. If I'm zooming into that first slide, this is the cloud bakery. So you have the base AMI, it rolls down the bakery floor, it turns in these two instances. You're able to insert any type of repositories, anything that's actually custom for that single solution. Then, at that point, you're able to install any type of custom applications. In our case, we have our Axway products. We'll be able to install whatever that version, whatever that type of software our customer needs in that environment, and it rolls down, and it gets born into an EC2 instance. And then within the CloudFormation templates, this fits into the bigger picture as I was describing before, where not only you have everything sitting in its own subnets and its own DMZ, its own backend, its own front-end type of systems, you have its own virtual private cloud as well. So each new customer that we provision has its own virtual private cloud. And this all comes together. You can see to the left and right, we have different production systems. This can be your DR, this can be whatever you want it to be. But we want to show together, and this is all automated. This is all comes together. This is not manual type of hands on the keyboard type of work. And I touched on this before. The best way to avoid failure is to fail constantly. And this really, I know I talked about the security monkey before, but this is the ultimate test of resiliency. I'm not sure that many people here can say with confidence if you go out and unplug one of your servers, that the service is still going to be up and running and you're not going to have too many complaints. These are types of things that you should be able to do on a regular basis when you have a true cloud environment. Because why not? If something fails and you know it fails, you can know what that looks like. You can script it to automatically become resilient and self-healing. Netflix is they're really one of the huge proponents in this area, and they've open sourced a lot of stuff. They've come out with their whole simian army, they call it. Probably the biggest and boldest thing they came out with is Chaos Gorilla. So if you're familiar with Amazon Web Services, they have certain availability zones within each region, and they have multiple regions throughout the entire globe. So in the United States, they have one in North Virginia, they have another one in California somewhere, and they have another one for government up in Oregon, I think it is. So within a single availability zone, though, you can have a Chaos Gorilla shut down an entire data center for whatever you're running, right? Not everyone else's stuff. But you can have it shut down absolutely everything that's running for you. This came in really useful a few years ago when Amazon actually did have this happen, and they had an entire availability zone go down, and every single customer went down in that availability zone, except for, you guessed it, Netflix, who actually was testing this, constantly having redundancy, and constantly testing their environment for these types of things. A few things for embracing the DevOps philosophy I'd encourage everyone to read. These aren't security books per se, but they're really critical in understanding how you can better manage these types of dynamic environments. Probably the one I would say is kind of security is Anti-Fragile from Nassim Taleb. He describes the property of anti-fragility, where there's no really word for being anti-fragile. We use words such as robust, resilient to describe things that are resistant to breaking. So if I have a steel pot and I drop it, it may be resistant, but it isn't anti-fragile. It doesn't become stronger because I did do that. Well, that's the types of environments we're trying to build that do become stronger because we actually have it undergo these types of stress tests. And what's next? Homomorphic encryption. This is probably one of the newer things that I think will really start to get a lot of things taken off in the cloud for a lot of businesses in a lot of those countries over in Europe. I have to deal with these things on a regular basis. Axway is actually a French-based company, and our largest revenue generator is actually based out of Germany. So we have a lot of privacy concerns from a lot of potential customers all the time. Even before they had Snowden stuff about 2 years ago, there was always Patriot Act, Patriot Act, Patriot Act. I mean, all the time we had to hear about the Patriot Act and how horrible we were as Americans and whatnot. And I guess it's kind of true. I don't know. But anyways, with the advent of homomorphic encryption, these are the types of things that will facilitate a lot more trust for cloud. So Alice hands Bob a briefcase. Alice wants Bob to count how much money is in the briefcase. And Bob naturally says, give me the key so I can open and count the money. Alice says, no, I want you to count it by just from the outside without actually looking at it. That's kind of homomorphic encryption. Be able to process data just looking at the encrypted bits. This is no longer theory anymore. There's been a few more updates on research I've seen recently that this is already actually happening. It's nowhere near efficient, but it's already actually happening. So the biggest hurdle's already been done. And digestible big data. I got a friend of mine who actually runs the security team over there at Microsoft and Azure. He doesn't hold too much against me because we run Amazon. But one of the things he shared with me was one of the coolest things they were doing over there within their security operations center, their SOC, was actually making big data much more digestible. As you're having so much more data than ever before, how do you actually respond? How do you actually alert to these types of things? So this is an actual screenshot of one of the things that one of the panels they actually have in their SOC. You can actually see and hear events as they're happening in real time. So you can see the analyst right there is kind of zooming into a subsection within a greater spectrum, and you can actually see and hear these types of events happening in real time. So with that, thank you, and that's everything else. I'm not sure if there's any questions, but no questions? All right, feel free to come up. I'll be around. Oh. No, you did not. So one of the pieces that actually I had the slide in here too. I think last time I did this presentation I ran over a bit more. Let's catch up after this because that's probably one of the ones I actually had a dedicated slide for this. I ran over last time I actually was giving this talk at CactusCon last week. And so they kind of scolded me. So let's catch up after this, and I think that's a very good question. The logging is one of the bigger things that we have to do. So, anything else? So because we actually don't have everything, we have everything located initially on the local servers, which come up and down. We use Splunk, so we use Splunk as our SIM. All that data is actually still kept and archived within Splunk, and we have that tiered out in several type of tiers. So for HIPAA, we have 7 years, for example, for those types of customers, and we have that in S3 bucket. So we still are able to maintain those types of and address those compliance regimes and whatnot, but we do it in a little bit of a different fashion. So when they come back and look at a server, we actually can't go to a specific server that was actually looking at, but we can go back to that overall service, and we can show them every single server that was potentially within scope of that, which always existed. And we can show them the assurance controls we have, and ensuring that all systems, that just because it doesn't exist anymore, that we have change control around the templates, we have change control and all the logs there within CloudTrail. We can go back and show them this is when the server was stood up, this is when the server was stopped. If they want to go through and look through a few hundred servers, have at it. I felt working with, we've worked with KPMG for our SOC 1 and ISO 20001 stuff, when we worked with a few other organizations in the healthcare space and also in the financial sector. As soon as you show them the assurance controls and you gotta really get them the warm fuzzies as far as what you're actually doing and it actually works well, they feel a lot better at it. And you can actually just go to Splunk and you can show them, this is what we've got. Oh, what server do you want to look into? We can show you all the servers that were terminated within the past year, past month. What do you want to see? All the servers that were started in the past year, past month. We can show them all that, and we can show them in a few moments, not even minutes. We can show them like a few seconds. It's an easy drop down. So once they kind of see we actually know what we're doing and you actually have a good handle of it, it usually gives people the assurance they need. And all the data is there. It's all within our Splunk indexers. So it's not actually hiding. It's not actually getting terminated. The servers are, because they're really ephemeral, that's just the processing piece. But the log data is still there. Anything else? All right. Thank you.